Hi, everyone. For measures of spread, we've had range, standard deviation, variance. Now we have the IQR, the interquartile range, which is Q sub 3 minus Q sub 1. It's the first quartile minus the first quartile. And this here represents the middle 50% of the data. Here, 87 minus 50 points is 37 points. Here, 30 minus 20 points is 10 points. That indicates tighter clustering about the median here. Q3 minus Q1, the width of the box, basically. In fact, one way to define outliers is that an outlier could be said to be more than 1.5 IQRs away from the box, either at the high end or the low end. Here's Albert Einstein. Don't worry, I won't enforce this in this class, but that is one way to define an outlier when you put an asterisk there. Let's take a look at real test data. These are two midterms from a calculus class that I TA'd. First of all, compare the spreads between the two midterms. It looks like the second midterm is more spread out, right? Look here, the standard deviation is 20 points over here, it's 16 points up here, so there's more spread here. Also, look at the IQRs. It's 22 points over here, it's 32 points over here. Stem and leaf plot, a stem plot, lots of scores in the 60s. Here are the high 60s, here are the low 60s. We have about a bell shape, roughly. We'll do scatter plots later. Box plot. All right, if you look at the box plot for midterm 1 and midterm 2. By the way, this is an ancient version of Minitab, like 1990s. Okay, I don't want to embarrass them. Look here. It looks like for midterm 2, it may have been a harder test. The scores overall were lower. The median was lower. Okay. And for midterm 2, the scores were more spread out. Clearly, the IQR was bigger, right? Okay. Here, the IQR was about 32 points as opposed to 22 points over here. Box plots, efficient ways of looking at distributions. So that's chapter 10, lesson 10.